Welcome to the Bentley Systems training course where you will learn how to load and analyze steel bridge structures in STAAD.Pro Connect Edition. This course is specifically designed for the students that are competing in the ASCE, AISC Student Steel Bridge Competition. In this course, we're going to be focusing on analyzing your steel bridge structure and reviewing the results. We are now going to turn our attention to our sample model that we created in the previous training course and videos. We're now at the point in our workflow where we've modeled all of our structural geometry, assigned properties, specifications, and support, and modeled all the loadings that might be required by the steel bridge competition rules. We're now ready to move on to the next phase, which is analysis and design. To move on to the analysis portion, we're going to go up to the Workflow Page Control area and select the Analysis page. We're going to notice that the Analysis Whole Structure dialog is going to appear in the Data area. Now, every single STAAD.Pro model must contain an analysis command before an analysis is invoked. And to access the commands, we're going to go up to our ribbon toolbar and click on our Analysis Commands icon. Now we have several different types of analyses available in STAAD.Pro. The first one is this first tab to perform analysis. This is going to be used to direct STAAD.Pro to perform a linear elastic analysis. In addition to that, we also have options to perform a P-delta analysis. We can perform a cable analysis, a non-linear analysis, and we can also perform a buckling analysis. In addition to that, if you are using the newer versions of the AISC 360 steel specification, we can also perform a direct analysis now. For this particular structure, we're just going to perform a simple linear elastic analysis. So I'm going to select the Perform Analysis tab, and then I'm going to click the Add button. And you can see that my perform analysis command has been added basically at the end of my input file. Once we're done, we'll go ahead and click close. Now at this point, if you are only going to be performing an analysis on your structure and doing the rest of the calculations by hand, you'd be ready to go ahead and perform the calculations and review the results, where you can take off things like member stresses, member forces, things like reactions. For this particular model, though, we did go ahead and assign a few AISC standard sections, and we can perform a code check on those particular members in STAAD.Pro. So let's go ahead and take a look at some of the design options we have. Up in the Workflow Page Control area, I'm now going to select the Design tab. My first thing that I'm going to do once I get to this area is I'm going to select my current code. And I'm going to select the AISC 36010 for this option. Now, the AISC 360 allows for two different steel design methods. You could either do an ASD or an LRFD approach. We didn't use any factored load combinations, so we're going to set our design method to ASD for this course. To select a design method, you're going to come down to your Define Parameters button, and you're going to find your method parameter, and we're going to make sure it says ASD. To be sure, we could just go ahead and click the Add button, and then we're going to go ahead and click Close. Now, in addition to specifying your steel design code and your design method, you're also going to want to take a look at all of your design parameters to see if any of them are applicable to your model and need to be assigned. Now, we're going to go ahead and take a look at things like yield strength of steel. Before I do that, I'm going to take a look in my status bar, and I'm going to see that my input units for length are currently set to feet. It would probably be a little bit easier to set this to inches when I'm ready to assign something like a yield strength of steel. So I'm going to change my input units first. To do that, I'm going to come up to my Geometry tab in my ribbon, and then click on my Input Units icon. And I'm going to change the length units to inches, and we'll click Apply. And then you can see my status bar has been updated. Now what I'm going to do is I'm going to go back to the Define Parameters button, and take a look at the rest of the parameters that we have available. Now, the way the design parameters dialog works in STAAD.Pro is that as we select different parameters, what we're going to notice is that this field is already filled in with some type of value. This value is considered the default in STAAD.Pro. So if I come down here and select FYLD, which is our yield strength of steel, I can see that the default yield strength of steel is 36 KSI when I select this steel design code. Now, if 36 KSI was applicable to the members of my model, I wouldn't need to manually assign a different yield strength of steel to it. I only need to go ahead and specify a yield strength if the default of 36 is not appropriate. For my particular model, I have a couple of tube sections which have a yield strength of 46 KSI. So I'm going to want to come up here and change my yield strength of steel. So I'm going to go ahead and say 46 KSI, and then I'm going to click the Add button. Now, in addition to that, you may want to look through any of these other parameters that you can find. Take a look at their default values and see if there's anything that's appropriate for your particular bridge structure. For our bridge structure, we're going to assume that these are all the parameters we need to assign. So we're going to go ahead and click Close. Now, as I come down here, I can see that the method parameter doesn't need to be assigned to anything in the model, but my yield strength of steel does. It needs to tell it which members have a 46 KSI yield strength. So what I want to do is I want to highlight this parameter and then assign it to my sections. The best way to do that is to use some of the options in the Select tab in my ribbon toolbar. So let's go ahead and go there. Now this is going to be applied to all of my tube sections, so the best way to do that is to select my members based on their property name. This is an easy way to make sure you grab everything that you need. So I'm going to grab my HSS tubes, and then we'll go ahead and say Assign to Selected Beams, and then we'll click Assign. Now I do have some angle sections also in this model, but I'm going to assume that 36 KSI steel would be appropriate for those members, so I don't need to assign anything else to that, as the default is automatically going to be assigned unless something else is assigned manually. Now, once you specify all of your steel design parameters, you then need to follow it up with one more step. And what we need to do is we need to tell the program that we want to perform a design on those members. And we're going to perform a design by using a check code command. So over in your steel design dialog, you're now going to click on your commands button. And we're going to select the check code command. Basically, what this command does is it instructs STAAD.Pro to check whether the provided section properties of the members are adequate. So we'll go ahead and say check code. We'll click Add, and then we'll click Close. Now in STAAD.Pro for the AISC 360 Steel Design Standard, we can perform a code check on any member that was assigned using a standard AISC section name. So we're going to assign this check code command to those particular sections. Again, it would be most helpful just to use the Select by Property Name option. And we're going to grab our angle sections and our tubes. You can hold down your Control key to select two at a time. I'm going to say Assign to Selected Beams, and then I'm going to click on the Assign button. Now at this point, we're going to go ahead and save our model, which would be required before performing an analysis. And then we are ready to go ahead and run the analysis. To perform an analysis in STAAD.Pro, you're going to come up to your ribbon toolbar and select your Analysis and Design tab, which is where you're going to find your Run Analysis icon. We'll go ahead and click on this. Now, if there was ever a time where some information was missing from your file, this might prevent STAAD.Pro from completing your analysis. So you're going to want to make sure you follow all of your modeling steps. Some of the things that would prevent a successful analysis from being performed is if you have some sections in your model that don't have a material or a section property assigned to them. You'll get an error if you did not model any supports in your structure, and your structure needs at least one load case to perform a successful run. Now, there may be a few other things that you want to take a look at, but those are a few of the things where you can have a problem. Now, once your STAAD analysis and design dialog appears on your screen when your analysis is complete, we're going to check this bar right here to see if we have any errors, warnings, or notes. If you have any information there, say you have an error or a warning, you'll be able to see that kind of information in the output file. We don't have any warnings or errors, so what we're going to do is we're going to proceed over to the post processor to get the information out of the program that we're going to need to complete our design. So we're going to go ahead and say go to post processor, and then we'll click done. Now, upon entering the post processor, the results setup dialog will appear on your screen with all of your load cases that you've currently modeled. Again, check your rules to make sure you've modeled a sufficient number of load cases to simulate the loading that may happen during the competition. What we're going to do now, though, before I click OK, I'm going to go to this Results View Options tab, and I like to enable automatic scaling. This will basically make sure that say, a deflection diagram or a stress diagram on my screen is exaggerated enough so that I can view the results easily. Once we're done, we'll go ahead and click OK. Now, there's a few things you're going to want to look at when performing your design or when reviewing your results. The first thing is you're going to want to look in your rules to see if there are any displacement requirements, and you're going to want to make sure that your bridge structure is not displacing more than an acceptable amount. So let's go ahead and take a look at how to view your displacements in the program. To view any of your information, you're going to go to this View Results area, and you're going to go to your Layouts icon. This will give you access to all of the different types of results we have available. And I'm going to start with the displacement option. Now, when the displacement option is selected, I'm going to be able to see a deflected structure on my screen. And this is going to be according to the currently selected load case. So here I have my lateral load test selected. I can also come up here and select my vertical load test if I kind of wanted to see how it's displacing. In addition to that, in addition to the graphical results, I have some node displacement tables that might be of use to you. Those are going to be located in the data area. If I select the All tab, basically what I can see is I can see the translational and rotational displacements for each load case in each node that is included in the model. So here you can see node number 1. And here is the displacement, translational and rotational for the vertical load test and for my lateral load test. I can also go to a summary table if I want to find out which nodes are giving me my worst case scenario, which might be, again, a helpful area for you to go to see, where's your maximum and minimum X displacement, where is it occurring, and for which load case it's occurring for. The next thing we're going to do is we're going to review some of our steel design results. So again, I'm going to return up to this Layouts area, and I'm going to come down to my beam results, and I'm going to go to utilization. This will give me the results of any of the members that were included in the check code command. So I'm going to take a look at my utilization results, and currently everything is color coded to show the status of the design. If anything is in green, it means that it fully passed the code check and gave you an interaction ratio less than 1.0. If anything is in blue or red, it means that that member is currently failing, and you'd want to go ahead and make some adjustments before completing your final design. For our design, everything turned out acceptable, so we don't have any failed members in our model. If we want some additional information, we can review the results over in the Design Results table in the data area. Here you can see every single member in the model that was included in the code check, and you can see its interaction ratio. If you want to double check to see if you have any failed members, you can select a Failed Members tab. If there are any members that have currently failed the code check, they're going to be listed here. Now, if you do have any failed members, what you're going to need to do is go back to your analytical modeling mode and change the properties of the member or some other configuration, and then reperform the analysis. STAAD.Pro is a finite element analysis program, and anytime you change any portion of the structure, it's going to basically remove the previous analysis and require you to perform a new analysis to access your results again to make sure everything is consistent from start to finish. Now, if there are any members that you did not include in your code check and you want to get forces out of the program, you may want to come back up here and select the Layouts tab, and we can get beam forces and also beam stresses. So here, let's go ahead and select my beam forces, and I can see force diagrams on my screen. Now I can change the different types of force diagrams by selecting these different icons at the top of the screen. I can also get the data for the beam end forces and the beam force details over in the data area. Now this concludes the process for designing your steel bridge structure in accordance with the Student Steel Bridge Competition as specified by the ASCE and AISC competition.
This video is part of the Modeling Steel Bridge Structures video series. A link to the series playlist is available here. If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.